Hello everyone, this is our channel's 11 subscriber special. We're actually at 12 subscribers, but I'm still working on that one. So we're at this problem called Cowlendar. So it's basically about this strange new timekeeping thing where there are n months, each with a specified amount of days, and several weeks, such that each month has at least 4 weeks in it, and there are at most 3 distinct values of a month modulo the week. And so here, you can't see it, but the constraints are insane. The months can go up to 4 times 10 to the 9 days, which basically tells us that, yeah, we cannot loop through every single L and check. But what we can instead do is make use of the pigeonhole principle, and this was pretty fun to learn about. And basically, the pigeonhole principle states that if you split n items into k boxes, then at least one box contains at least n floor of n divided by k plus 1 items. And so it took me a while to get this because I kept thinking the items and boxes were different things. But in this case, the amount of items is how many distinct months. For example, there are 3 distinct months here, and the number of boxes is equal to the three distinct values of a month's days modulo the week. And so, for example, let's see over here. Okay, let me put this. So this means that if we take 4 distinct values, at least 2 of those values will have the same result mod the week, if the week is correct. So this is basically a way to very, very greatly narrow down how many weeks there are, and just get past that pesky restriction that makes weeks range from 1 to 10 to the 9, which we can't do. And so how do we implement this? Now, it turns out we start from sampling the first 4. We sample the first 4 values of distinct values of months. It turns out we don't need to sample the others because L will be common in all of them. All we need to do is to eliminate false positives, which are the only side effect of only sampling the first 4. So we sample the first 4, and we find the number of L's that cause at least two elements to have the same result mod L. L is the number of days in the week, by the way. And then after we do that, we essentially just have to check for false positives. And to do that, we just loop through every single candidate for L and then brute force, because there's at most like 200 values of L, and that's a massive low taper fade downgrade from 10 to the 9. Okay, and you might be wondering, what do we do in the cases where it's literally, what do we do in the cases where there are only 3 months? You can't take a sample of 4 from that, right? Well, yeah, we can. But we can use something easier, because it's literally impossible to dissatisfy the 3 distinct values, since there are only at most 3 months. And so we literally just have to get every single week value from 1 to the maximum amount of weeks, which is dictated by each month is at least 4 weeks long. All right, and as you can see, we can choose our files, and yeah, thank you for 11 subscribers or 12 subscribers. Yeah, AC. Thank you for watching, and goodbye.